in the two-way table, one category is represented by rows, and the other category is represented by columns. This is different than the Venn diagram, which I'll just move this over, so we're looking at the Venn diagram. We don't have rows and columns in the Venn diagram. We have those like two circles, and we're putting data in the different circles or in the intersection of the circles if it fits in both, and on the outside of the circle. Now, I have a question for you. If you complete a Venn diagram in another class, and you're probably more likely to do it like maybe in English or science class, if something has stuff in common, you put it in the middle in the intersection, correct? Do you also put it in the other circles? Riley's shaking her head saying, no, why would we do that? We put it in the middle, and that shows it goes for both, right? Okay. So let's say, for example, we're talking about students here. And let's say Faith is one of those 16 students who belong in the middle. She plays an instrument and she speaks a foreign language. And let's say Faith would be one of the 16 names here. Would Faith's name also be one of the 25 or one of the 30, or are those separate? Faith, you're saying yes or no? I should put Faith in both. Put her in both or put her in one? If I put her in the middle, do I need to put her in this big circles? No. Okay, so this is something that's going to be important for us to realize. That number of 16 in the middle represents the people who do both things. I only need to write their name one time in the middle. I don't need to also put them in the outside bubbles, because then how many times am I counting Faith? 2 times, maybe 3 times if I put her in both of the bubbles and the middle. And how many of the Faiths are there? There's one. And do not be confused. So that should be some good things to help you. What I want you to do next is fill in the table. So make connections from the Venn diagram to the table, and I'll give you some time to fill those in on your own. And something that's interesting so you can check if your table is correct. This total column, 46 plus 34, equals 80. This total row at the bottom, 41 plus 30, also equals 80. Okay? If you maybe put a number in wrong somewhere, then those things wouldn't equal the total number of people that we surveyed, and that would be kind of like a warning sign, like something's not right. But again, the piece that I was trying to get across before is like where 16 people speak an instrument and, speak a foreign language and play an instrument, okay? When we do the people who play an instrument but don't speak another language, we use that number 25. Instead of like doing 25 minus 16 and getting 9, that would assume we put them in both. But if we put them in the middle, we won't write them twice. Okay, we don't want to overcount people. What I want you to do next is there is a table down at the middle part of your page there, and I would like you to fill in that table. Okay, and on the left side, it's going to ask you questions just like how many students do this, how many students play an instrument, how many students speak a foreign language. I would ask that you try to focus on your table here, not your Venn diagram. So use the table to read that information for me. And then on the other side of it, you're working with the same number, but now you want to do a probability. So think about basic probability from Monday. How could you calculate the probability? So again, I'll give you some time just to kind of fill those things in, and I'll be walking around to see if there's any common. One of the reasons I asked you to focus on your table and not the Venn diagram is because the table is a great way to organize all of your information. If I ask you the question, how many people play an instrument? If people look at the Venn diagram, you're likely to answer 25 because you see it right underneath play an instrument. If you look at the table over here, how many people play an instrument? The 16 people who also speak a language and the 25 people who don't, so a total of 41 people play an instrument. Okay. Same for how many students speak a foreign language. If you just look at the Venn diagram, you might be tempted to just answer those 30 people, but you're leaving out the 16 people in the intersection who also speak a foreign language, and those are 16 different people. So we want to say how many people speak a foreign language. We're reading that top row. It should be the number 46. Now, for the other ones, I think we're okay, and we'll choose values that are, coming directly from your Venn diagram. We'd have 16, 9, and 25. And then can I have a volunteer, somebody who would describe to me, how did you answer the questions in the right column when it asked for probability? What changed in your answer? How about this? Turn to your shoulder buddy at your table. How did you calculate the probability in the second column? Speak now. Okay, Eric, can you tell me how you calculated the probabilities?
I just took the number from the left side of the table and put it over.
Yeah, just divide it by 80, right? So I'm going to write and not reduce my probabilities here, but for the probability that a student plays an instrument, that'd be 41 out of 80. Here we have 46 out of 80, 16 out of 80, 9 out of 80, and 25 out of 80. Okay. Now, I'm not going to take the time to simplify my fractions or to plug this into my calculator and get a decimal, but you certainly could to get a final answer for your probability. Okay. But the key piece is, today we're going to have two different types of tables. Some tables, like the one we have on the screen right now, where we're just counting up the number of people that do a certain thing. And then other tables we're going to create are going to have probabilities in them, so we're going to have to divide the numbers by the total. Okay. So let's move along, and we've got some vocab to write down, okay? Starting with a two-way table. We know a two-way table shows the same information as a Venn diagram, but we're going to define it as a frequency table. So frequency means how often something happens, that displays data from one source that belongs to two different categories. So in that example that we were working on at the beginning there, our one source is the 80 students we surveyed. The two different categories are playing an instrument and speaking a foreign language. In a two-way table, you have something that are called joint frequencies. Joint frequencies are all entries in the table. You can think about joint frequencies as the data that you've collected. So like how many people are doing foreign language? How many people are playing an instrument? I'm going to flip back to the previous slide, and I'm going to highlight where the joint frequencies are on the table. Okay, so if we go back to the previous slide, and we're looking at our table, these four boxes in the middle here, where I'm tabulating how many people play instruments and speak languages, those are my joint frequencies. So they're just single entries in the table. Those are joint frequencies there in the middle. Not in the total columns. The total columns have their own name, and that goes back to our vocabulary. They're the marginal frequencies. Okay, so the marginal frequencies are the sum of joint relative joint frequencies in the rows and the columns. The marginal frequency is the sum of joint frequencies. In the word marginal is the word margin. Where are the margins of a paper? Along the top and the bottom, the right and the left, right? When you set your margins. Or think about, I'm sure you've talked about people on the margins of society. What do we mean when you're margins of society? You're on the outside, the marginalized. Okay? So when we go back to the table and we look for marginal frequencies, they're the frequencies on the outside of the table. Okay, so there are totals. Okay, so these numbers right here on the outside there, these are marginal frequencies. Now, the next definition is very similar to one we've already defined, which is a joint frequency, which is the entries in a table. Now we're calling it the joint relative frequency. So think about what the word relative means. Relative really implies there's some kind of relation going on. And a lot of times when we compare relationships to numbers in math, we call those ratios. So the joint relative frequency is the ratio of a frequency that is not in the total row or column to the total number of entries or outcomes. Joint relative frequency is a fancy way for saying probability. So I'm going to write next to this, I'm really just calculating a probability. The marginal relative frequency then is also a probability, right? It's a relationship of the marginal entries to the total entries. So I'm going to say it's the sum of your joint relative frequencies in rows or columns. So it's really the same thing as a marginal frequency, which is the sum of your rows and your columns. But here, instead of adding the number of people who do something, we're adding the probabilities that they do something. So again, a marginal relative frequency is just a probability. And the last one that we have is a conditional relative frequency. Let's go. Get that to go away so people can see that a little bit better. Hang on. There we go. I'll move this up. This is the ratio of a joint relative to a marginal relative. The big difference here is it's no longer in relation to the total number of outcomes. It's in relation to one of the sums of your rows or your columns, and that means it's really a conditional probability. So marginal relative and joint relative are just really basic probabilities. This here is a conditional probability. Definitely take the time to reread this and then also think about what that looks like in the tables, and we'll talk about them as we work through some of the examples on the back side. But the book will use these terms like joint relative, marginal relative, so you need to know what it's talking about when it says those things. So let's look at some examples. We'll do example 1 together. We're going to create a table, basically, in example 1. So if you flip over to the back side, it says, you randomly survey students about whether they're in favor for planting a community garden at school. Of the 96 boys who were surveyed, 61 are in favor. Of the 88 girls who were surveyed, 17 are against. Organize the results into a two-way table, and then after we're done with that, we're going to find and interpret our marginal frequencies. Okay, so the key to creating a two-way table is, remember that two-way tables represent data in 2 different categories. Decide what your 2 categories are going to be. Let's share out, what do we think we could create for 2 categories in example 1? Boys and girls could be 1. What could be the other category? In favor and against. And it doesn't matter how you set it up, like rows or columns. Okay, people's tables can look differently. I'm going to do boys and girls, and then I'm going to add something for total. And then for my columns, I'm going to do for and against. And again, I'm going to add a column for total. So really the big thing here is like remembering to add that total. And then once you got that table set up, once you decide on your 2 categories, it's really just a matter of kind of filling in the numbers. So similar to what you did from the Venn diagram. This time we don't have a Venn diagram, we just have information. If I read that second sentence, it says 96 boys surveyed, 61 are in favor. So I can put 61 in the entry spot for boys who are for the garden. And I can put the number 96 in the total boys. And then through some reasoning there, we could say how many boys must be against this garden. 35. You got 96 minus 61. You can do the same thing for the third statement. Of the 88 girls, so that's my total, 17 are against, which means how many were for? 71? 71 girls were for. How will you fill in that bottom row? Just add down. So add down here, I'll get 132. Add down here, I'll get 52. And then I can check to make sure all my numbers are right, because 96 plus 88 must equal the same thing as 132 plus 52. It should come out to the same total, which this ends up being 184 either way I do it. So we made the two-way table. Okay, we did that. Now we have to find and interpret the marginal frequencies. Remember what we said in the definition. Where are the marginal frequencies? On the outside of the table. Okay, so we're going to focus on these 5 numbers for our marginal frequencies if they ask me to interpret those. And I'm just basically going to write a short summary of what happened in my survey. So things I might write would be, I'm going to start by saying 184 students were surveyed. Okay, so I talked about that corner marginal frequency. I can say 96 were boys and 88 were girls. So I talked about the column. And the last thing I can say is 132 favor are for the garden. And I've got 52 against. and I just summarized or interpreted my marginal frequencies. So that's really all it's asking you to do. Do I have to talk about those other numbers in the middle of the table? Nope, because it doesn't ask about the joint frequencies. Okay, it just says interpret your marginal frequencies. Are there any questions on how you can create your own two-way table? I think the most important thing that I can tell you when you're working on homework assignments is you have to decide what your two categories are first. Once you get the two categories, everything kind of falls into place when you're putting the numbers in. On the next example, can I have you take some time to try to fill in the missing numbers? So use your reasoning skills. I like to think about it sort of like a Sudoku puzzle. Once you find one number, then you'll find another number that kind of fall in line. So see if you could get the table filled in. We're going to do that. Faith, I'm going to ask you, which one of the first ones you did? She did 70 in the top right box in the marginal. And how did you know it was going to be 70 up here? It has to equal 130. So you're essentially taking the total 130 minus 60, right? Okay. Then you could use that same method to answer our total for tardy arrivals, right? 130 minus 58 is 72. So we've got those filled in. Find one row or column where you know two things, and then you can find another thing. Once you have those filled in, now you can kind of fill in the missing blanks in the tardy column and the walking column, right? 72 minus 22 is 50, and 70 minus 22 is 48. And then for that very last box, you could think about 58 minus 48, or you could think about 60 minus 50, but either way you get the number 10. So again, you got to take it one at a time, and you got to find one that you know for certain before you do the other ones. Now, this direction is wrong. It says then use the two-way table to create a two-way table that shows joint and marginal relative frequencies. I should have put in there. I apologize. I forgot the word relative. But remember, what are we going to think about when we see the word relative? Really just means, what's our whole chapter about? Probability. Okay, so it's really just asking us to do the probabilities in the boxes. The probabilities compared to the total. So what's our total number of people surveyed here? 130. Okay. To get the numbers that we're going to put in here, we're just going to take our entries, like 22, and divide it by 130. So this first box is whatever 22 divided by 130 is. Now, I would say most of the time when you create this relative frequency table, you'll just put in the decimals. I'm going to write out the fractions for the top row just so we know where the numbers came from, but then I'm just going to fill in the decimal value of them. So for on-time walkers, I would do 48 out of 130. And for total walkers, I would do 70 out of 130. And I could do that for all the rows. 50 out of 130, 10 out of 130, 60 out of 130. 72 out of 130, 58 out of 130, 130 out of 130. But you don't normally have to leave them as decimals. You can put them in as, or sorry, leave them as fractions. You can put them in as decimals. And I'm going to round to the nearest hundredth on mine. So we could now use the relative frequency table to answer questions like, what's the probability you walk and you're on time? And then I'll just find that place there, and I got a 0.37 probability. Or what's the probability you ride the city bus? We just look in the total column, 0.46. Okay. So we're just provided with probabilities there. Is everybody okay with that? Justin, did you have a question or just stretching? Okay. The last example that I want to show you really quickly is, this is a relative frequency table that's already been calculated for us. So notice that in the entry spots, we have decimals already. Okay, so we're not counting up the parents and teachers, we just know their probabilities. And part A asks you the question, what's the probability that a randomly selected parent voted to eliminate the class? So what we're talking about here is really a conditional probability, and the condition is that we select a parent. So when we calculate this probability, we're actually going to only focus on the parent column. We should figure out what's the total for the parent column, so 0.58 plus 0.06, which gives me 0.64. And out of that 0.64, that's the probability they're a parent, what's the probability they voted to eliminate the class? We're going to say their responses in answering the question, should you eliminate it? So we want to know, what's the probability they said yes, given that they were a parent? The probability of yes is 0.58. The probability of a parent is 0.64. So we're just taking 0.58 divided by the total, and that will be our probability that they said yes, given that they were a parent. That comes out to be 0.91. In part B, instead of focusing on the parent column, you're focused on the student column. So now you need the total students. You'd add those guys up, and you'll get 0.23. And we want the probability they didn't want to eliminate it, so no, given that they were a student, we'll do 0.15 divided by 0.23, which is 0.65. Your assignment's on the bottom of that page. Finish your 10-1, 10-2 assignment if needed.